Hello everyone, and I thought what I'd do today, or for this video at least, is to show you around the applications that I've created that I've posted around the place, and I built a website. Now, I used to have these applications as BlastCalc and VibeSD on the App Store, but when the App Store fees got a bit too troublesome, and every edition of the iOS system, the operating system, would create additional problems that you needed to depreciate and then reissue, and you had to build a different icon because screens kept upsizing and all these sorts of hassles, when all I wanted to do was provide some applications to help. And I had originally charged something like $3 for them, and it was they didn't make any money essentially. So I have decided that after going to an ISE meeting the other day, which is the International Society of Explosive Engineers, I went to one of the chapter meetings. I decided, after talking to a couple of people, that I would try and rebuild these for HTML, JavaScript. Well, modern browsers these days are capable of doing a lot of the stuff that the early iPhones used to be able to do. So anyway, without further ado and enough of the waffling, I thought I would show you what these applications do, or what they're for. And so here we have on the left hand side of the screen, got blasting calculated, vibration, overpressure, ideal decomposition of nitromethane. That's a new one that I've just added. I didn't originally have that on the App Store. And a bit of information about the calculations that I used during to make these applications. And down the bottom, the important thing is, if you want to support me in creating these applications or making videos or anything like that, or talking about blasting, and you don't want to pay through the nose, but you think I'm worth $5, then buy me a coffee down here at the by Brenda Coffee. So let's go on to a blasting calculator. This was originally packaged as BlastCalc. Now, I had originally thought about having more than one, like making an equilateral pattern, equilateral staggered pattern and a staggered pattern, but I decided that, I just boiled it down to the simplest stuff. So that's up to you to decide on what your pattern size is, whether it's equilateral and that's what you want to stick to, or whether an obtuse pattern or a different size pattern would work for you. Obviously, different blasting results would need different patterns, obviously. For example, armor rock, you want a much larger burden than you do spacing. Anyway, so here we've got, and we can just look at the attributes. We can import any of these sorts of attributes, and down the bottom here we get calculations. Now, it's set up for a iPhone looking thing, so if we turn around and go to the developer tools here for us, we can just have a little preview of what a iPhone would look like on an iPhone, or if, say, I don't know, you've got a Galaxy Fold or something like that, or a Pixel 2, pretty much the same, right? So a little bit of a test, rightio. So we can go back and have a look at this, and we can just decide, well, where we're going to do let's say we're going to do a 6x7. And so as we change these numbers, this changes. These attributes down here change, as you can see right now. And let's say we want a 4.2 meter stemming with a 1.5 subdrill, maybe a bit excessive for some people, and 229 mil hole, and we're just going to go with ANFO. Let's go with ANFO, or let's say we will die this up and do an average in hole of 1.22, and change this to let's say we're using Dyno Products T2065G. Now, this is just a text field, so you type whatever you want. So if you decide that you're not going to type it, then that's what your decision is. And obviously, when we change these, we can see if we can dial this down, and we're looking for a 65% emulsion phase in this particular product as per their naming convention. So at this point, we'll dial that. We end up with a 35% ANFO and a 65% emulsion. Let's say we're in hematite, and well, we're not going to use nano, we're going to use electronic, and let's say we have our spacing time at like something, I don't know, let's say we're at 12 milliseconds in our spacing time, and our burden is something like 60, and you can write in here, I did great on this app, sort of thing. Radio. And once you've done that, this is all this down here has changed, and gives you all the statistics related to it. Gives you your powder factor volume. It's a 0.93. That's huge. But again, iron ore isn't hard, it's heavy, and so a lot of people love lifting and fluffing iron ore, and because it's a bulk, and you don't have you do have ore dilution, but not so much with gold. I mean, the entire Pilbara is red, and it's red because there's a lot of iron ore in there. Sort of just a few ratios there, and we can see what our timing relief is at 10. Now, some people might say that, oh, that's terrible, but it's iron ore, and it goes up rather than across. The blasts are quite large there, so they're large surface areas, and you can see all these attributes in there. So it just sort of like gives you a review of what that blast would look like in terms of resources and ratios. This is what BlastCalc does. So you can do a little review. You can send that to yourself via a little email, and send that to yourself, or maybe somebody else that you've been talking about on Bench. If you've got internet connection, then this would work. And so we can go back, or we can go on to the vibration calculator. We'll just go back, and we can see here that we've got vibration and overpressure. Now, originally I packaged these as VibSD together. So there was a vibration or an air blast part of that equation. So the difference between the vibration is essentially just this equation down here, which is the scale distance, like a scale distance equation. You can pretty much calculate any of these values. So say you know what your peak particle is because you recorded it, and so let's say you recorded 10 millimeters, and you know the distance. So there's a value that and you know that the charge that influencing weight charge is, and you say, I don't know, what's 1,000? Let's write 1,000 kilos. So let's say you did 1,000 kilos, then that will produce your K value, predictive K value, based on that distance from the site, with this weight of influencing charge and that recorded value. So you can start recording these, you email it to yourself, and that's essentially, what your regression analysis would use. So you can do that. Anyway, you can do whatever you like with this. It's a single point. It's not a super complex. It's just the AS2187 equation from the Australian standards, from the Appendix J, and it's just that equation in a calculated format. And the overpressure is the same. Overpressure is the same, except that this also has a sound pressure level conversion in it. So then you get decibels out, and the equation is down here. So essentially you can use it however you please, but thought this was useful. I originally had made these applications to try and get some kind of money out of it, but now I've just packaged them because I've talked to a few friends of mine and a few people in the industry, and they loved them, but they were no longer available. So I've made them available. So if you spread the word, it'd be great. I'd love to see them get use. Here I have added an additional one called the ideal decomposition of nitromethane. A lot of people were concerned about carbon output. However you feel about that, that's beside the point. However, these are the applications, and I thought you'd enjoy them. And last of all, I've got a calculations page where you can read up or look at all the calculations that I've used in creating this application, and as and when I get more time, I will put more calculators in here, hopefully. Anyway, I hope you enjoy the applications that I've created, and I hope that they're shared around the industry and around new players. They're a good touch point, good reference for your rules of thumb. A lot of calculations are in there that you would use. So these formulas are all in Excel format. So you should be able to just select this equation and copy it into Excel and attach the correct cell reference to the value you want to produce, and you'll get this. By all means, point out if you feel that there's any errors in any of this work. But I hope that you enjoy it. Leave a comment, share this video, like this video, all that sort of stuff that people say. And yeah, good blasting. I hope that you enjoy the video.